Welcome back, friends. So in the previous session, we don't have much time to discuss here. Let's say, suppose if a signal is delayed by 2 seconds, functionally we have to replace t with t minus 2. Graphically, the signal has to be shifted right side by 2 seconds. That's what the meaning of it. Whereas if a signal is advanced by 2 seconds, that means functionally we have to replace t with t plus 2, and the graph has to be shifted leftwards by 2 seconds. That's what the meaning of advance. Suppose somebody has given like this. If the signal is delayed by 4 seconds, that means functionally t has to be replaced with what? T has to be replaced with t minus 4, and graph has to be shifted rightwards by 4 seconds. That's what the meaning of it. So delay means leftwards. Delay means rightwards and advance means leftwards. That's what the meaning of it. Okay. In general, suppose if you know a signal x of t like this, in general, lies between two samples t1, t2, t. So amplitude may be k. Then to find x of t minus t naught, what we have to do is add each and every instant with t naught. t1 plus t naught, t2 plus t naught. That's what is happening here. Suppose if it, let's say here, just it is existing between 1 and 3, which is similar to this one, t1 value, t2 value. X of t minus 2, to find out that, in graph we have to add each and every instant with 2. Then plus 2 plus 2, that is nothing but 3, 5. That's what it is going to be. Next, suppose if you try to find out x of t plus t naught, then what we have to do? We have to subtract each instant with t naught, t2 minus t naught. Like that we have to do. So suppose, let's see, I am finding out x of t plus 2. That means each instant has to be subtracted with a 2. That means 1 minus 2 minus 1, 3 minus 2, that is 1. That's what it is happening here. So this is what in general what we have to do. Okay, take a note. So be careful whether it is a left shift or right shift. Advance means left shift and delay means right shift. Okay. I hope you have taken this. Next operation, what we have to see is time scaling operation. Time scaling operation. If you know x of t, From this, if you find x of at is called as time scaled version of x of t. Time scaled version of x of t. Okay. Now let's see. Here we are having two cases. What are the two cases? You can understand easily. Again, I am taking the same example. One, 3. Let's say 1 x of t. So x of t is equal to 1 when t lies between 1 and 3. T lies between 1 and 3. There is a mathematical representation. For this, if I try to find out x of 2t, it is also equal to 1 when argument lies between 1 and 3. This is the limits of 2t we got, but we require the limits of t. Then divide each instant with 2. Then 1 by 2 less than t less than 3 by 2. If I draw the signal, how it look like? One by 2, 3 by 2 t. This is what? X of 2t. Next, suppose if I try to find out x of t by 2, this value is equal to 1 when 1 less than t by 2 less than 3. These are the limits of t by 2, but I want the limits of t, then it is 2 less than t less than 6. If I draw this signal, how it look like? It is existing between 2 to 6. 2 to 6. This is x of t by 2. Now try to understand. From this signal to this signal, x of t, x of 2t. T has to be replaced with 2t. Graphically, what is happening here? Amplitude is not changing. 1 here, 1 here, 1 is also there. But only thing we have to observe, width of the signal. What is the width of the signal here? 2 seconds. Whereas, what is the width of the signal? 1 by 2 means 0.5, 1.5. 0.5 to 1.5, this is nothing but 1 unit. Whereas, 2 to 6, this is 4 units. Now, here, 2 units width signal became 1 unit width signal. That means the signal got compressed. Next, 2 units signal width becomes 4 units. That means the signal got expanded. That means this is nothing but expanded version and this is compressed. I can say this is nothing but the signal got compressed by a factor of 2. The signal got expanded by a factor of 2. That's what the meaning of it. That means in time scaling there are two possibilities. One is a compression, another one is a expansion. So the signal may be compressed, the signal may be expanded depending on the a value. So if I say x of 2t, whenever you see x of 2t, that means it is a compressed version. If you see x of t by 2, that is nothing but expanded version. That is as simple as that. Suppose let's say if a signal got expanded by 4 times, the signal got expanded by 4 times. That means functionally what are the changes we have to make? Functionally t has to be replaced with t by 4. That means t by 4 is nothing but the expanded version. Whereas suppose if the signal got compressed by 3 times, by a factor of 3, then that means t has to be replaced with 3t. I hope you understood. So take this. Time scaling. Suppose x of t exists, let's say between t1 and t2. Suppose if you try to find out x of at, then what we have to do is t1 divided by a, t2 divided by a. Divide each instant with a. That's what we have to do. Amplitude does not change. X of, let's say, t by a if you want to find out. Then what we have to do is multiply each instant with a at1, a t2. Amplitude is 1. That's what the meaning of it. In general, this is what we will do. Okay, take it. Okay, so this is about the time scaling operation. Let's see the next operation, which is nothing but time reversal operation. Okay, time reversal. If x of t is given, from this, if you could find x of minus t, then it is nothing but time reversed version of x of t. In time reversal, what are the changes in function? T got to be replaced with a minus t. T has to be replaced with a minus t. Those are the changes we have to make in the function. Okay. Then graphically, what are the changes we can see? Let's say, again, I am taking the same example. T 1, 3, 1, which is x of t. So mathematically we can say x of t is equal to 1 when 1 less than t less than 3. This is what the mathematical representation. If I could find x of minus t, how it look like? So x of minus t is also equal to 1 when the argument lies between 1 and 3. What is the argument here? Minus t. Then these are the limits of minus t, but I want to find out the limits of t. Then multiply minus 1 on both sides. But here minus 1, this has to be changed. This inequality also has to be changed so that we can write minus 3 less than t less than minus 1. So how it look like? Between minus 1 minus 3, whose value is 1. This is x of minus t. So if you observe carefully, what is the changes we have done from x of t to x of minus t? Functionally, means in the function we replaced t with minus t. That's what we have done. And graphically, what is happened? So here the graph is actually taking the mirror image, or we can say folding is happening. Suppose if I fold this one, so it will go to 3 goes to minus 3, 1 goes to minus 1. That's what the happening here. So I can call this as a folding with respect to y-axis. With respect to y-axis, or mirror image with respect to y-axis. With respect to y-axis. That's what the meaning of it. If you take another example, you can understand easily what is it means. Let's say this is x of t signal. Try to draw x of minus t. Try to draw x of minus t. That means we have to fold with respect to y-axis. Then this triangle will go here, 1 goes here, minus 1. Next, this will be folding like this, so it will go to plus 3. Like that. So this is what x of minus t, which means we have to fold the signal with respect to y-axis, or we have to take mirror image with respect to y-axis. That's what the meaning of time reversal. Or simply we can say multiply each instant with minus 1. Minus 1, if I multiply it with here, so 1 becomes minus 1, 3 becomes minus 3. That is also one way to say it. Okay, take it. Sometimes we will encounter with multiple operations. That means time scaling, time shifting, time scaling and time reversal, time shifting. These are the combinations they can give. So that, let's say, try to understand this. If x of t is known, from that, let's say we have to calculate x of, let's say, at plus b. We have to calculate this. Means we have to draw this signal. Then what we can do? So here we are having two methods. One is called as natural method, another one is unnatural method. Method 1, how we can apply? Natural method. Natural method. Okay. So in the natural method, first let's see, listen carefully. What are the operation does it have? So it looks like it is having a shifting, it looks like it is having a scaling also. So it is having both shifting and scaling. So which one we have to apply first? Do we have to apply first scaling, then shifting, or we have to apply first shifting, then scaling? Then which is the method? So in the natural method, we take first shifting, then scaling. X of at plus b. So in this direction we will move. In this direction we will move. That means first we do the shifting, then we do the scaling. Okay. So listen here, you can understand. First we know the original signal x of t. From this, if I take shifting by b, shift by b, then shift by b means t has to be replaced with t plus b, then x of t plus b, or directly I am writing advance by b, so t has to be replaced with t plus b. Okay. Next, what I have to do to get x of at plus b? That means t has to be replaced with at, that means scaling by a. That means scaling by a. Scaling by a. That's what the meaning of it. Okay, so I hope you understood. So in the natural method, whatever is visible, that's what we have to do it. That means b unit shifting is there, so first we are doing the shift by b. Next, a is the scaling factor, so we are doing the scaling by a. That's what we are doing here. Natural method. Next, method 2. Method 2. That is, let's call it is unnatural method. In the unnatural method, we will go in the opposite direction. X of at plus b. That means in this direction. First scaling, then shifting. So let's say one by one. X of t, I know it. From this, I have to get x of at. If I want to get x of at, what we have to do? Scale by a. Scaling by a. Then t got replaced with at. Next, from this, I have to get x of at plus b. X of at plus b. That means we already know x of at. From this waveform, I have to get x of at plus b. So many people will say, what is the operation I have to do means, so many people will say t has to be replaced with t plus b. That means advanced by b units, which is absolutely wrong. Why? That means, let's say, if I take a wrong method, what will happen? Let's say shift by b. Shift by b means t has to be replaced with t plus b. T has to be replaced with t plus b. That means x of a t plus b. Finally, this is x of at plus ab. That is what we require. No, that is not the correct answer. So we cannot do shift by b units. Then what we can do? Shift by b by a. Shift by b by a. Then t got to be replaced with t plus b by a. T plus b by a get cancelled. Finally, we are going to get x of at plus b. So this is what we have to do. So that means first we have to make the changes here. First, to apply the unnatural method, a has to be taken common, t plus b by. So this is the way we have to go. So listen carefully what I am trying to say. In the natural method, to apply the multiple operations, that means we have to go from right side to left side. So in this direction we have to move. So in this direction, if I try to move, first I can apply the shifting by b, then scaling by a. That's exactly what it looks. I am doing that natural method. But in the unnatural method, what we will do, we will go in this direction. That first scaling, then shifting. How much scaling we have to do? The same way, that is nothing but a is the scaling factor. Then how much we have to shift? It is not b here, so it has to be b by a. Then only we can get x of at plus b. So it is not b, it is b by a. So do you understand why it is called as natural method, why it is called as unnatural method now? So because the whatever the visible here, we are doing that. That's why it is a natural method. Whatever the visible shift we are having, that's not the shift we are doing here. We are doing b by a shift. That's why it is a unnatural method. That's only the difference. Okay. Namesake only, these are natural, unnatural, but still you can understand it easily. Okay. You can go anyway. So any method you can go, that doesn't matter. But still you can get the same answer finally. Okay. Take it. Multiple operations. Let's say we are having x of t, x of minus t plus b. So here also it is having two operations. One is a time reversal, another one is a shifting. Here also we can go with a natural and unnatural method. Method 1, natural method. In the natural method, what we do is, if I try to find out x of minus t plus b, the order of operations are in this direction. That means first shifting, then time reversal. So how we can do that? Let's say x of t is given. If I do time shift by b, then t has to be replaced with t plus b, x of t plus b. Then what we have to do to get x of minus t plus b? That means we have to do time reversal. Time reversal means we have to replace t with minus t, then we can get obviously x of minus t plus b. So in the natural method, whatever it is visible for us, that's what we are doing here. That means shifting by b units, shifting by b units I am doing. Next, it is a time reversal, I am doing the time reversal. That's what the meaning of natural method. Next, in the unnatural method, method 2. which is unnatural method. Here x of minus t plus b. We have to follow the order of operations in this way. That means first time reversal, then shifting. So let's say if I know x of t signal, to get x of minus t, first time reversal. First operation is time reversal. Next operation, what we have to do so that I can get x of minus t plus b. So many people think that, so it may be plus it is looking like, so we have to do the advance. No, we have to do the delay by b units. Delay by b. Delay by b means t has to be replaced with t minus b, then x of t minus b. Finally, this is x of minus t plus b. X of minus t plus b. Yes, that is a correct answer. So here I can write advanced by b also, no problem. Advanced by b. So it looks advanced by b, so advanced by b, time reversal we are doing. But in the unnatural method, after time reversal, so even though it is looking like advanced, but we have to perform the delay. Then only we can get the final answer correct. Okay, take this notes. Let's say x of t is there. We have to get x of minus 80. So which operation we have to perform first? Is it scaling or is it time reversal? So it doesn't matter. So whatever the operation you perform, it won't make any difference. So method 1, method 2. So order of operations is not important. Order of operation is not important. You can do anyway. That is, first way we can say first scaling, then reversal. This is the one way. Second method, first reversal, then scaling. It doesn't matter. Whatever the operation you are performing, what is the order of operation you are performing. Okay, take this. Okay. Let's see one example. You can understand how to apply the multiple operations. X of t is given like this. Let's say minus 1 to 3, whose amplitude is, let's say, 1. This is x of t. They want to find out from this x of, let's say, 2t minus 6. 2t minus 6, they want to find out how we can do that. So first I will go with the method 1, natural method. method 1. So in the method 1, to find x of 2t minus 6, we have to go in this direction. That means first we have to find out the shifted version. That means x of t minus 6. So how we can calculate x of t minus 6? So that means we have to shift the signal by 6 units. Then where it will go? Let's say for the easy purpose, let's take this is a 4. For easy purpose only I am making this is 4. Okay. So if I shift it, then what will happen? Minus 1 shifted to 6 units. That means it will go to 5. And 4 goes to 10. 4 goes to 10. That's what the function x of t minus 6. Then x of 2t minus 6. That means we have to scale it. That means compress it. If I compress it 5 by 2, then it is going to be 5. So finally this is going to be 2.5 to 5. So this is what x of 2t minus 6. First we are finding out x of t minus 6. Then we are finding out x of 2t minus 6 from this waveform. This is the one way. Next, let's say method 2, which is an unnatural method. Can I get the same thing or not? Method 2. That means x of 2t minus 6. So to go in this direction, first we have to take 2 common out. 2t minus 3. That's what we have to do. So in this direction we have to apply the operations. First try to find out x of 2t. X of 2t means each instant has to be divided with 2. Minus 1 by 2, 4 by 2, that is 2. Minus 1 by 2 and 4 by 2, which is nothing but 2. Then we have to calculate x of 2t minus 3. That means what is the shift we have to perform? Delay by 3 units. If I delay by 3 units plus 3, then it is going to be 2.5 to 5. Are they same? Yes, they are exactly the same. Both are same. Okay, 2.5 to 5, 2.5 to 5. So whatever the operation you are performing, that is a natural method or unnatural method, it doesn't matter. Finally, you have to get the same thing. But only thing is, in the unnatural method, you have to be careful. First, we have to take the 2 common out. Then only we have to perform it. Okay, take it. You have to remember. We know u of t. How it look like? Can you draw u of minus t? If you fold it, you are going to get this kind of thing. Up to 0, its value is 1. After 0, its value is 0. Next. Can you draw u of 2t? That means each instant has to be divided with 2. If each instant is divided with 2, it won't make any difference. You are going to get the same thing, which is nothing but 1 only. That is also equal to u of t. U of 2t is also equal to u of t. That's the one thing. Next, u of minus 2t. Already we got u of minus t. So if I divide each instant with 2, it won't make any difference. Still we are going to get u of minus t only. Which is u of minus t. So from this, can I conclude one thing? U of at can be u of t can be u of minus t. That means it is nothing but for a greater than 0, for a less than 0. That's what the meaning of it. Okay, take it. Given x of t waveform, which looks like this, zero, 2, 1, and given y of t waveform, which looks like this. And they said y of t is equal to a x of small at plus b. Then what is a, small a and small b values? What are these values? That is the question. Okay. This is an example. Can you solve this example? That means they have given two waveforms and they have given the relation between them. Then they want to find out those constants. Okay. First, one by one, let's see. A value 1 may be not equal to 1. If you observe carefully, the amplitude of this waveform is not changing, 1, 1 only. That means capital A value is 1, that is fixed. Next, small a value may be 1, may be not equal to 1. If its value is not equal to 1, then there may be a compression or expansion in the signal. So let's check it out. Do we have any compression or expansion? First, try to understand. What is the width of the given signal, which is nothing but 2 seconds. What is the width of this signal? That is also 2 seconds. So from this, can I say the width of the two signals is same? That means we don't have any scaling factor. That means A is also equal to 1. Then only one thing it is having here, the signal is shifted by 4 units. Then we got the original signal. This is y of t. That means I can write y of t is equal to x of t minus 4. That is as simple as that. If I could write like this, then can you tell me what is the a value? 1. Small a value 1. B value minus 4. That's what it is. Take it. In the next question, suppose if it is given y of t like this. Again the same question. Find capital A and these things. So again capital A value is equal to 1. Now we have to find out small a value. So let's see. What is the width of the signal here? The width of the signal is 4 to 10, that is nothing but 6 seconds. That means the width of the original signal is 2 seconds, whereas y of t is 6 seconds. That means the signal got expanded or not. By what factor? By 3. So 2 became 6, that is nothing but 6. So small a value, so many people think that it is 3. A value looks like 3, but not 3. Suppose if I write 3t, that means it is compressed, but we require expanded version. So what we have to do? We have to take a value is equal to 1 by 3. So for that, let's say, first, I don't know how much shift we have to do, but how much scaling we have to do, we know that. So go with that example. So go with that procedure. First find out x of t by 3. Already we know x of t. From that x of t by 3 we have to calculate. How we can do that? T by 3 means we have to expand the signal. That means 0 to 6. 0 to This is one. Now we got x of t by 3. You tell me what we have to do with this signal x of t by 3 so that I can get y of t. That means what is the operation we have to perform on this signal so that I can get this one. That means I have to forget about this one. Forget about the function. Just see the waveform. What we have to do this waveform? We have to shift this waveform right side by 4 seconds. Can I get the y of t? That means if I want to shift a waveform right side by 4 seconds, that means t has to be replaced with t minus 4. That is as simple as that. So I can write y of t is nothing but x of 1 by 3. T is replaced with t minus 4. So finally x of t by 3 minus 4 by 3. So here a value is equal to 1, small a value is equal to 1 by 3, small b value is equal to minus 4 by 3. So be careful what we have to do with the waveform so that we can get this one. Okay, take it. So in general, a value can be calculated by the formula available width by required width. This is the formula what we have to use to find small a. So in this case available width is 2, required width 6. So this is nothing but 1 by 3, like that. Okay, take it.